Hey, good morning. We're going to do a quick lesson on acids and bases, how to identify if a reaction, in fact, is an acid-base reaction. We'll look at some definitions of acids and bases. Okay, so I believe this is like topic 4.8 or something. Just come on. Just waiting for my screen here. There we go. All right, so let me get my pen. Okay, acids, bases, yeah. All right, what we want to focus on here, I'm sorry, I'm going to clean that up. When we talk about acid-base reactions, is we have a transfer of hydrogen ions. Okay. If you think about acids and you think about bases, you want to think that acids, we know that they're sour, corrosive, they've got a pH that is less than 7, and they have an excess of hydrogen ions. Bases, we know they're bitter and slippery and in lots of cleaning, and they've got a pH that is greater than 7. And they themselves have an excess of hydroxide ions. So I think it's important that when you consider acids and bases, acids and hydrogen always go together, and then bases and hydroxides always go together, okay? If we look at acids and bases that way, and we look at reactions, we see that we have a transfer of hydrogen ions. Now, a hydrogen ion is often referred to as a proton, okay? And it is synonymous to this ion here, which is called the hydronium ion, okay? That's an O. And it is called protonated water. And hopefully you can see why, because it's water with an extra proton, giving it 3 H's and a positive charge. They can be used interchangeably. If we look at the Bronsted Lowry definition of acids and bases, we see that an acid is a proton donor and a base is a proton acceptor. All right, so the acid is the giver of the hydrogen, and the base is the taker of the hydrogen. That's the way you would visually see that in a reaction. So when you see an acid-base reaction, you'll have one species. Let's give our strong acid. One species acting as an acid and another species acting as a base. And what in fact here happens is, because this is my acid, he's going to give away his hydrogen, and this water will play the role of the base. Bases take. So he will lose his hydrogen and turn into chloride, right? And water will gain the hydrogen because he's playing the role of the base and turn to the hydronium ion. Now, the acid's partner is called the conjugate base, and the base's partner is called the conjugate acid. So what we have here are conjugate acid base pairs. There are two of them, right? We've got two conjugate acid base pairs. This being 1 and this here being 2. The conjugates are always the product side, and the regular acids and bases are always on the reactant side. Okay? So you need to be able to identify those conjugate acid-base pairs. If there are none, then it's not an acid-base reaction. Okay? Okay. Let's look at one more thing. Let's do one more. Let's go like this. NH3 plus H2O. This time it's a weak. Don't worry about the double arrow. And we're going to get NH4, and we'll get OH negative. Okay? So what I see is NH3 appeared to take the hydrogen. Therefore, he played the role of base. H2O appeared to lose a hydrogen, so he played the role of the acid. Therefore, NH3 over here, NH4 will be my conjugate acid. And for H2O over here, OH will be my conjugate base. So once again, we have our conjugate acid base pairs. Notice that in the second one, water is playing the role of the acid, and in the first one, water is playing the role as a base, or playing the role of a base, rather, right? So what that means here is that water playing a base and water playing the role of an acid is water is amphoteric. And you could infer that that means can be both an acid and a base. Right, and you might be thinking, well, how do I know which is going to occur? And that's where we have something called Ka and Kb values. But I don't think that we need to get into that right now, okay? This is not the time for that. What you need to be able to do is look at a reaction and identify, is this an acid-base reaction? Or is it, and if such, it could be a neutralization reaction. Let's go ahead and make sure that you realize that. When a strong acid, right, reacts with a strong base, you end up with a neutral salt and water. Okay, so we call this a neutralization reaction. Right, classic example. Well, let me write it in the order that I wrote it up above. Let me write the neutral salt first and the water second. Okay, you might be thinking neutral salt. Yes, some salts can have basic or acidic properties, but those salts are not formed by strong acids and strong bases. And we will talk about that more later. It'll be a different unit, okay? So I'm going to leave this at that. I think that's, you should be able to identify if a reaction is a neutralization reaction, if it is an acid-base reaction. Okay? All right. See ya.